This is one of the more difficult problems that we will see in this section. There's more information given, which basically means that we have to do more to find our solution. Here we are given that both -4 and 1 are zeros of the given function, and then we are asked to find the remaining zeros. Well, one of the things that we need to do is be able to be given the zeros and also know what the factors are. So in other words, if we've been given that -4 is a 0, we need to know that that also means that x plus 4 is a factor. Okay, and then likewise, if we've been given that 1 is a 0, we need to know that that means that x minus 1 is a factor. Now, you don't have to write this next part down. I'm going to actually erase it when I'm done. But think about what we know about factors. If I tell you that 2 is a factor of 20, and I tell you that 5 is a factor of 20, what do I also know? I know that if I multiply 2 and 5, then that number is also a factor of 20. That's basically the situation that I have up above. I know that x plus 4 is a factor of the f of x function, and I know that x minus 1 is a factor of the f of x function. That means if I take the product of the two factors, then that resulting product is also a factor of f of x. So we're going to use that fact to start our problem. All right, so x plus 4 times x minus 1, which equals x squared minus x plus 4x minus 4, which equals x squared plus 3x minus 4, is also a factor of f of x. Okay, so basically here, if you're given two zeros, rewrite the zeros as factors, and then those two factors being factors of f of x means their product would be a factor. So multiply the two factors together to find a new factor. Now what you're going to do with this new factor is you're going to let it become the divisor so that you can find other factors. So in this problem, we're going to use that new product. We have x squared plus 3x minus 4. That's basically the largest factor that we know of f of x. And then we're going to divide. Okay, the f of x term or piece goes on the inside of my division here. This is x to the 4th plus 9x to the 3rd plus 22x squared. Now notice that we're missing an x term. There must be an x term. And so what we're going to do is we're going to put a placeholder and say plus 0x and then minus 32. I tell students when we're dealing with placeholders, what would you rather have? $11 or $101? Having that extra 0 in the actual digit makes all the difference in the world. The same thing with polynomial division. If you do not put the placeholder, it's going to make a huge, huge difference to working the problem, and you will make mistakes if it's not there. All right, to perform this division, I want to look at the x squared and the x to the 4th. What times x squared gives me x to the 4th? Well, I've got two x's, I need two more, so I need to multiply by an x squared. Take this x squared, distribute it to each of the three terms we have here. So x squared and x squared is x to the 4th. X squared times 3x is 3x cubed. X squared times -4 is -4x squared. Notice that my like terms line up underneath each other. Draw a line, change your signs. Okay, after you change your signs, you want to combine downwards Those will cancel. 9x cubed minus 3x cubed would be 6x cubed. 22x squared plus 4x squared would be 26x squared. Notice that I have 3 terms out here. I also need 3 terms down here. So at this point, I would need to bring down the 0x. Okay, I'm going to erase some of my scratch work here. From this point, I need to start over on my division. Look at this term here and this term here. What times x squared would give me 6x cubed? Well, I would need a 6 for sure, and then I need an x. I need to get x cubed. I have x squared, so I need one more x. Multiply the 6x by each of these 3 terms. 6x cubed plus 18x squared minus 24x. Draw a line, change your signs. Okay, the 6's would cancel, and then I have 26 minus 18, which would be 8x squared, and then I have 0x plus 24x, which would be just 24x. Bring down your last term. So you have 3 terms here. I'll come back, erase some of this. All right, and now I need to start over on my division. Look at the x here, x squared there, sorry, and the 8x squared. I would need to multiply simply by an 8. Take that 8, multiply it to these 3 terms, and then put the result underneath below. 8 times x squared is 8x squared. 8 times 3x is 24x. 8 times negative 4 is negative 32. Draw a line, change your signs. 8x squareds cancel, 24x's cancel, 32's cancel. Remainder is 0. All right, so what I was given is I was given 2 zeros that I was able to rewrite as 2 factors. I multiplied the factors together, used that result as my divisor. I now have remainder 0. That's a good thing. If I'm asking you to find the zeros of a particular polynomial, then you're going to be guaranteed that when you divide by whatever I've given you, your remainder is going to be 0. What does that tell you? That tells you that this quotient is another divisor of f of x. So what I need to now do is I need to now write my f of x function in terms of the divisor times the quotient. So I would write this f of x equals, I divided by x squared plus 3x minus 4. I got a quotient of x squared plus 6x plus 8. I got a remainder of 0. Because the remainder is 0, I need not write that part. Now remember where my original divisor came from. This divisor that I have here, that I just erased, that was x squared plus 3x minus 4. That divisor that I had here came from these 2 factors. So I already know how that factors. So if I come down, then I know these 2 factors are x plus 4 and x minus 1. Now I need to factor the second group. Well, I need factors of 8 that add to 6. I can use 4 and 2. Okay, now notice if we're trying to find the zeros, we would have set f of x to 0, we would have factored, which is done, and then notice that we have 2 factors that are repeated. The x plus 4's are repeated, so write that as squared, and then the x minus 1 and the x plus 2. Okay, if I'm now being asked to identify the zeros, if x plus 4 is a factor, then x equals negative 4 is a 0. That's the first one we were actually given. If x minus 1 is a factor, then x equals 1 is a 0. I was given that one. If x plus 2 is a factor, then x equals negative 2 is a 0. That one I hadn't been given. Also notice that we can talk about multiplicities. The understood powers on these last two factors are 1. The power on the first factor was 2. So this 0 has a multiplicity of 2. Both of these have multiplicities of 1.